In today's class, I'll be showing you how to monitor aerosol level in any region of your choice. So the first thing to do is to pick a region of your choice. Which region are you going to monitor, or are you working with? In this case, we are going to be using the administrative boundary to select our region of interest. So in this case, we search FAO. FAO got Global Administrative Unit Layer, first administrative unit. So we import this as a table. Import it again. Import it. Then after importing it, I want to work with Kano. So Kano is a northern state in Nigeria. So I'm working with Kano. Now I will use this marker here to select the region I'm working with, and I will have to filter this region out from the administrative unit. And to do that, I will take a variable. And call the variable region of interest ROI, and this will be equal to this table here dot filter bounds function. I will filter this geometry out from it. So with this function, I've been able to filter this administrative unit called Kano State out from this table, because this table contains list of administrative units: Kano, Gwamawa, Pakistan, what have you, all over the world. It's a global data set. So from this global data set, I've been able to use this function to filter out my region of interest, and my region of interest here is Kano State. Now there are 4 steps I will show you in order for you to work effectively with Aerosol Optical data, MODIS Aerosol Optical depth. Now the first step is what we just finished doing, selecting the region of interest. However, we need to show this region of interest and put it on our focus. So to do that, we use the map dot center object, and we are going to center this object, which is the region of interest, and we are going to use a zoom level of 8. Now we need to see what we just finished doing. To do that, we use the map dot add layer. We use the map dot add layer function ROI. So if I should run this, you will see the output. Click on run. Okay, good. So the region of interest has been selected. This is the first step of all remote sensing, selecting your region of interest. Now the step 2 is to pick the data set of interest. Now we are going to be working with Aerosol Optical depth, and we are going to be using MODIS dataset. Now this is the one we are using, MODIS MCD 19A2 version 6.1. So let's click it. Then collection snippet. I'll click on I'll copy the collection snippet. I'll come here. I will take a variable, and this variable I will call it the collection. I'll call it the collection that I'm working with, or you can call it any name. I'll call it dataset. I'll call it dataset. So this is my dataset, and my dataset is equals to what I just finished copying. Now in my dataset, there are various bands, and I need to select the specific band I'm working with using the select function. And how would I know the specific band I'm working with? I will go back to this dataset bands. You look at it. I'm selecting this optical depth 4047. Now I have copied it, And there is a scale factor here, so I will show you how we can use this scale factor to multiply our collection so that we can have a good result. So you come here, I've pasted the particular band I am interested in working with from this data set. Then I will use the date function also to pick out the exact date I'm interested in working with. So let's use the filter date function. So this filter date function, I'm working with February 2024, starting from 1st, then I will end 2024 February 29. Okay, so I've been able to select my data set. However, I need to apply the scaling factor. Now, how can I do this? To apply the scaling factor, I'll be using the function. I'll create a function to do that, and I'll call it scaled NDVI. First of all, take a variable, and this variable, let's call it Aerosol Optical depth, not NDVI. I just finished working with NDVI data. Scaled Aerosol Optical depth. So this is the name of the variable. You can call it any name at all, and this will be equal to the data set is what I'm working with. Now, from this data set, I will use the map function. Map, then take the function. From the function, I will need the image, and this image, I will return this image and return image, then multiply the image with 0.001, then copy properties, image of the image then use the system time start, system time end, system time start, system time end. So let's print out what we just finished doing to see how many images we have. Print the scaled ADVI, the scaled Aerosol Optical depth. Use the size function and run it. The date range is not date range, bad date 2024 02 01. Okay. Got you. So it's running. We'll look for how many images we have. In this case, in the whole of February, we have more than 36,000 images. Now, these images is too many. What we need to do is to reduce it to mean. We just need the mean value of all the images taken within this period. So let's take a variable. Now this variable, we'll call it average aerosol optical depth, and this will be equals to the scale aerosol optical depth dot reduce. We are going to be using the EE dot reducer function, reducer dot mean. Now, this image that we just reduce with the mean value, we clip it to our region of interest so that we'll see the results in this area we have selected only. Now, for us to be able to see what we just finished doing, we need to visualize it, and visualization parameter has already been given in this case. So we just go back to that code snippet, or we'll copy the code snippet from, copy the visualization parameter, paste it here. However, I like to change my own. I just want to see low, medium, and high. So then we have to print out this, we have to display this result. Everything we have been working on, we have not seen it yet, so we have to display the results on this map. And how to do that is to map dot add layer. Now in this case, we are going to be adding the mean aerosol optical depth. We are going to be adding the visualization parameter, which is subject to change very soon, and we are going to be calling the output aerosol optical depth. So click on run. So our result is here, but we cannot gain any insight from what is here, just showing everywhere green. Then we have to come to these layers, aerosol optical depth, go to settings. Then this custom, change it to 98%. Then click on apply. 98%, hold on. Okay, click on apply. Wow. So I will replace this place with 0.3. what I'm seeing here, the range. So I want to replace, the minimum is 0.351 and the maximum is 0.821. 0.821. So click on run again. So it means this region is highly polluted with aerosols, which is a process to particulate matter. Just like the region where there is green, it shows low aerosol level. The region where there is yellow, medium aerosol level, and the region of red, high aerosol level. So it means more than half of the state is polluted with aerosols, which is a process for particulate matter. And we know that aerosols or particulate matter causes serious respiratory problems and cardiovascular issues, including various health complications. Now, to present this result, because this result is still on the cloud, now to present this result, we can export the map out from here. Now, you just use another function, a code. So, this is the code to export images out from Google Earth Engine. Use the export .image to drive. Use this export.image to drive, and in this place you create a dictionary. From this dictionary, the first input is our image. The second input is the description of your image. And the third input is the folder you are sending the image to in your Google Drive. Then the fourth should be the region of interest. Then the fifth should be the scale you are using to export, and probably the maximum pixel that you are collecting. So the image is the average that I want to export. Then the description, let's call it Kanu. Let's call it Kanu Aerosol Optical depth. Then the folder, let's call the folder Google Earth Engine. Then the region we are interested in is our region of interest. Then the scale is 1000. Look at how you get the scale here. This is the scale band. The resolution, so we are going to be using the 1000 meters. The scale, which is the resolution, 1000 meters. And the maximum pixel, we are going to be using E1, E13. So just to add this, then we are done. So once you click on run, it will appear a task, Kanu Aerosol Optical depth. So if I click on run, you will start downloading your image. So this image, you can import it to QGIS or ArcGIS for further processing. So this is the code to write out or to get or extract aerosol optical depths, that is aerosols in cities. And from my result, I can see that Kanu is highly polluted.